Thank you. Good afternoon, and thank you for staying here until the last session, hearing me. I'll try to be brief and easy to digest. My name is Ami. I'm from Afeka. Afeka is an academic college in Tel Aviv, focused on engineering. I would like first to thank the organizers of the workshop for inviting us to present our view with regard to speech and NUI, and especially Avi Mendelssohn, which we are in very good contact with Afeka. A word about the place that I'm coming from. First of all, thanks to my colleague for participating in the research that I will present and assisting me in preparing the presentation. ACLP is Afeka Center for Language Processing. We are focused on research and development projects in the arena of spoken and written language, but actually most of the projects are in speech processing, and the vast majority of the project is actually in speech recognition. We were established less than 3 years ago, and since then we were quite lucky to receive about 5 grants from various sources. And since we are working with the industry, we had about 6 projects with the industry, part of them with companies abroad. We have established a multidisciplinary team, which is composed of linguists, software, electrical engineering, signal processing. If I may comment on a remark that was in the previous panel regarding the difficulties between engineers and designers, so we have faced these difficulties and still facing these difficulties in the connection between electrical engineering and linguists, but the outcome is much, much better, and the result of the research are definitely worth it. Another aspect I want to comment on is the issue of industry-academia cooperation. We have done most of our projects, beside I think 1 grant from Mossad, the Ministry of Defense in Israel, are done with the industry. And I found the Magneton, a platform in the chief scientist, quite attractive. It encouraged transfer from technology to the industry, 2 years, $1 million budget. We finished 1 project with a company called Speech Models, and we have started just now another project with NICE. In both cases, a team of 10 people, 5 from the industry, 5 from the academia, working together for 2 years. Quite a nice project. So that's about us. What I'm going to talk about in the 20 minutes or less that I was given is basically a short introduction to automatic speech recognition, the basics. Then I will extend a little bit and describe additional speech processing technologies which we believe should be used in NUI also. I will briefly describe what we are facing in the everyday life of speech recognition on a one modality speech-driven interaction. And then I would like to present my view, how do we take the speech recognition, the speech technologies, and integrate them into a real multimodal interaction, because what we are having today is not a real multimodal interaction. It's parallel modalities that each time we are activating a different one. And then I would like to describe a speech-driven human-robot interaction research that we are conducting at the ACLP. And one last slide with regard to our thoughts, what's next in speech recognition. Current status with regard to speech recognition technology in one slide. Speech recognition engines today are language dependent. You want to perform speech recognition in a different language. It is basically the same engine. You need to train everything. You need to have a completely different language package. The phonemes, the underlying units which are composing the words, are modeled by hidden Markov model. This is the leading approach. Search for the most probable sequence of words is done by language model and lexicon, which are coming from the linguistic field. It's basically a statistical data-driven approach. Performance is very sensitive to various issues. The main are any mismatch from training condition. You train in microphone, recognizing telephone. You train in quiet, you recognize an SNR in a car of 5 dB. You're facing major difficulties. This is the one major obstacle. The second one is the perplexity of the grammar, which is composed of the vocabulary of words. As you increase the vocabulary or the utterance length is larger, performance decrease. Performance is very specific to the evaluation point. It depends on the channel, on the noise, on the vocabulary size, on the grammar complexity, etc., etc. The main challenge today, I think, is robustness on all aspects to real-life conditions. If you take a look at the deployment status globally, we can see deployments in various market segments. I think led by the call center, where you can show an ROI, medical transcription, mobile, definitely with the Siri, and telco. I think that based on my knowledge, at least 70% of the deployments are in North America, and the North American English is well developed from the point of view of speech recognition. Again, language dependent. There's quite a large number of deployments which are domain specific, meaning you are recognizing only the vocabulary, the language model, and the utterances of that specific application. You need always tuning with speech recognition. You're deploying a first phase, you're collecting data from the field, you're retraining the acoustical model, the language model, the prompts, the grammar. There's a large phase of tuning, and then it needs some ongoing support. Most of the deployments were server-based deployments, meaning the speech recognition resides in the back office, and the recognition is performed either you call from a telephone or from a client, but the back-end ASR, and there is a shift now to the cloud. I think that the last year or two, I see more and more demand for embedded, the speech recognition engine that needs a lot of processing power and memory can reside on smartphones, and mobile devices and consumer market begin to put the need to have the speech recognition on the device itself. And I think that since last October, at least I feel it, there's quite a change in the arena of speech recognition. The launch of Siri made a lot of noise and a lot of request and demand, even in other vertical markets with regard to speech recognition. So Siri, Google Voice, and Google Voice Action definitely in the last year has made some kind of noise that should be still learned how it will influence the other vertical markets. So we got a virtual assistant like the Siri or the Google Voice Actions that you can ask whatever you want. Voice search, instead of texting your request, you can say your request while you're driving your car. Additional important issue from my point of view are the integration of speech recognition to artificial intelligence technology. And I will describe our research. We are doing something similar. Embedding the speech recognition into the operating system. And if we see what Apple has done, there's a migration from text, touchscreen, speech recognition, but still that should be all composed into some kind of multimodality. The main motivation, at least the main motivation at one of the main paths of speech recognition, is to enable easy and natural dialogue between human and machines. But just as a remark, speech recognition is used in one major path to human-machine communication, but in another major path to transcription of data. There's a lot of data which is audio or multimedia content, in which you transcribe the audio track to text, and then you can index the text and search or retrieve in the data like you are doing to textual data. This is definitely getting a push once the video is penetrating into the internet. But this talk I'll focus on human-machine interaction. If we take a look at the speech signal from the point of view of data, we got the content, the words that have been said, the speaker, the language, the emotion, and the emotions by the speaker, and the environment. As a signal processing person, when I'm looking at such a signal, it's a random process, many languages, dialects, potentially unlimited number of words, speaker-dependent characteristic, no distinct boundaries, etc., etc. Quite a complex signal to analyze for a signal processing person. And then, once you see the content, you understand the nature of the signal, you look at the market, you see various companies that are focused on one type of technology. There are technology vendors of speech recognition in various modes, like vocabulary, keyword spotting, phone recognition, grammar-based, but everything under the umbrella of speech recognition. Speaker verification or recognition, language recognition, emotion detection, meaning technology has evolved to extract the specific data out of the speech signal. And I'm mentioning here text-to-speech. It's not a speech processing technology, but under the framework of human-machine interaction, it's worth to mention it. Basically, you speak, the ASR transforms the speech to text, which is going to some kind of a machine. That can be just an application, that can be a mixed initiative dialogue, that can be artificial intelligence. It highly depends on the application. It handles the dialogue, it can execute tasks, it can answer, and it can activate the text-to-speech to speak. Watching a little bit or getting farther into what are the blocks inside, there is a speech recognition engine, which basically, it's a complex technology, but basically it transforms the speech into a sequence of text with considerable amounts of errors, substituting words, deleting words, or inserting words. Then there's a phase of speech understanding that is taking the words and trying to extract the meaning in the relevancy of the application or in open relevancy. So it can be some kind of NLP algorithm, which is fully textual and take into consideration the errors of the speech recognition, but part of it can be also embedded in the speech recognition, like the semantic interpretation standard that has been developed by the W3C. Then there should be some kind of dialogue management and speech production. These are the four ingredients. If we took another step further and take a focus on the speech recognition engine, the decoding is actually a search, a classical search algorithm, dynamic programming one, which is using various sources of data. The acoustical model are hidden Markov model, which model the probabilities to receive the feature vectors of the speech from the phonemes. Pronunciation lexicon is a table which describes each one of the words by a sequence of phoneme, and the language model describes the probabilities of the words to come one after the other. All these constraints and data are fed into one dynamic programming process in order to limit the search space and to receive the most probable word sequence representing the input speech. I talked about the technology until now, and we always forget, and I did the mistake several times. I was focused on technology, once going to deployments. I served several good years in the industry. We were developing technology, going to trials in Cellcom partner. We forgot that there is a person at the other side that does not speak exactly as we wrote the sentences in the grammar. Okay, so people have the tendency not to respond to questions. Even very easy and specific questions are not always speaking in an organized manner. And in the speech recognition engine, we estimate language model from text. So we would expect them to speak like it's written in the book. Major problem. So we need to adapt our language models. And even if you are talking about a specific application that you need to order flying tickets from a destination, from one place to another, and the whole vocabulary is 2,000 words, you discover that there are many additional out-of-vocabulary words said by the humans, large number of hesitation and tendency to interrupt the machine. All of this should be taken into consideration once developing or designing the human-machine interaction. Now I would like to talk a little bit about, at least my view, how speech should be integrated into a multimodal application. So we have chosen the four most used modalities, but any other modalities can be integrated inside. So there is gestures that can be, these are the sensors, mic, keyboard, touchscreen, and camera. These are the technologies that are processing the data that is coming from the sensors, and here we got the results. So currently, to the best of my knowledge, all the four modalities are working in parallel, and each time either the user chooses or the mixed initiative dialogue application, meaning the application receive what the user said, and in some cases can initiate an answer or even a question where some kind of data is missing, but each one of them is working by itself. Definitely speech. The sensor of the speech cannot be open 24 hours a day. The best system would result with a number of false alarm of the speech recognition engine that would not enable a commercial product. So the mode of work is selected, the modality is selected by a personal preferences or environment-specific convenience. I guess that if you are driving your car, you would prefer to dictate your SMS via speech, but if you are in a conference, you would prefer to dictate or to write your SMS message under the table so nobody can see. Okay, so this is the current state as I see it. A first stage should be that the speech processing should be extended to include not only speech recognition, it should include all other technologies. Speech recognition can be either word spotting, because in some cases you would like only to locate the words in order to understand the meaning. In some cases you would like to transcribe everything. It doesn't matter. Speech recognition, both of them, speaker, language, and emotion. So as a first upgrade, you should take all technologies in parallel, working on the outcome of the microphone. The language recognition can enable you to activate or change the language during the call due to various reasons. So the language recognition engine is working constantly. The speaker the speaker and the emotion can enable personalization on various levels. But a problem that I faced when I was selling speech recognition engine to application developers, they always told me there are 5 engines, each one of them with an API. I need to integrate to each one of them, and to do a tuning phase, this is not easy to do. I need a good reason. So this, together with the question how the various modalities can work together automatically and offer natural interaction, lead me to the next 2 suggested steps. The first one, an integrated speech engine, not 5 engines. I think that very easily we can develop the same joint feature extraction. All engines are doing feature extractions. It can be definitely a joint modeling, acoustical phoneme modeling for language and speech recognition, and other types of modeling. All modeling today are based on HMM. And then several parallel classifiers, but that are working on the same underlying feature extraction and modeling. And then, in my vision, I see that I input speech and I receive a file that all the data is received, like some kind of indexing, which is definitely good for ASR in human-machine interaction, but is definitely good for call center application like NICE and Variant are doing. They are recording the whole calls, and they need to transcribe the calls, and then to do search based on whatever you want. You would like to search for the file that somebody spoke and said that specific word, and he was very angry. So a one unified engine. One aspect can be that a post-processor should integrate all the engines, but I would prefer, that's not an easy task, online transmission of data for error correction between all the engines. But there will be only one output from this unified speech engine. And then the last point is that the various modalities, the 4 that are here and additional ones, should adopt the same model that I suggested for the speech. It would be a one speech engine transforming one unified output, and I think that all the modalities, not easy at all modalities should be synchronized and work together. So again, it can be some kind of a post-processor that receive all the output and integrate them, or get decisions based on knowledge base, but I would prefer, because I like machine learning, I would like an audio-visual large representing database in which you estimate the patterns for the various modalities. Meaning there will be gesture patterns and speech recognition words, and if somebody nods with his head and there is yes, there is a connection and tying between them, the confidence level of the overall recognition of the application is much higher, and there can be an error correction between the modalities, but the final will of the user is more important than each one of the recognition errors inside, so there will be a one comprehensive understanding of what the user wants it to do. Two slides about what we are doing in Afeka. We got various projects. You are invited to come to visit whenever you want. We got a large yearly conference by June 20, where the whole industry and academia dealing with speech is coming to Afeka, and then we are presenting our work. You're most invited to come to join. Here I'll describe relevant to the topic research, speech-driven human-robot interaction. Again, funded by MAFAD. This is the second year, and we're going to start the third year. It's a domain-specific. We've chosen a domain. We have developed a combined speech and text processing capabilities. A high-level flow is as follows. The speech input is fed into a speech recognition engine. Results are textually analyzed. We have developed a compensation model for the ASR errors, because you cannot use classical NLP methods working on text. The text we see from the speech recognition engine has a lot of errors. Not a lot, but got errors that affect the results. So we have developed some compensation method for it. Then it is matched to a textual database. The mass matching response is passed through TTS. And we got some preliminary dialogue which handle errors and confidence level. I think that tomorrow we are receiving our robot. We order it now. And we are porting the technology that we have developed to now. And the next step are to improve performance, definitely, to extend the dialogue, and at a later stage to enable now to search on the web the answers to the questions he doesn't know how to answer, and then on a constant learning from the interactions with the user. This is a block diagram. I'm not going to go into details. Speech recognition engine, our speech recognition engine based on HTK, but now we got our own speech recognition engine. This is a full block of text analyzer. The first year of the grant, we cooperated with Bar-Ilan University, Professor Ido Dagan. And this is the block diagram. Avatars and humanoid robot, I think you have seen enough today. What's next? Last slide. The main issue is robustness, especially, I think, in the environment of Kinect at home, new TVs. The target environment, from my past experience in speech recognition, is very problematic here. Noise, and especially remote microphones. We in speech recognition are used to cooperative speakers and to talking to the mobile nearby, talking to a TV or a game 1.5 meters with an omni microphone, getting all the noises. Quite a challenging task for a speech recognition engine. Non-native speakers, meaning Japanese or Israelis like me that are trying to speak English, and the acoustical models are trained on North American English, problematic in speech recognition, and multiple speakers. A game at home, the kids are talking to the game and talking between them, it's a problem. Bargain, when you're used to a system, you don't have the patient, even if you're not Israeli, you don't have the patient to wait to the prompts. You want to barge in, okay? So barge in, the capability to do recognition while the system is prompting the prompt. Adaptation mainly to channel environment, but to the speaker. I strongly believe in adaptation to the speaker, definitely in consumer products when you can estimate specific language models for the speaker. Spontaneous speech with all its complexity. Performance on spontaneous speech is much, much less than performance on read speech. Confidence level for the dialogue management and out of vocabulary handling. One short note, since I saw the topic, I just want to say that we have established in Afeka another center that is focused on mobile intelligent experience, and I think is very relevant to the topics that has been discussed here. So if somebody wants to cooperate or to discuss with them, Mr. Ron Aronson is here. You're most welcome to talk with him. Thank you for your patience. Questions?